Welcome back to another episode of Klipshow from the ground up. As if we didn't have enough to be thankful for on this channel, I did want to announce that since our last episode, we've crossed 200 subscribers on this channel. I expressed my gratitude for 100, and I'm in even more disbelief that we crossed 200. So thank you to everyone who enjoys this content. I'm always looking for your feedback. I want to give to this community. I love software engineering, and I want everybody to learn all the benefits that can be had from it, or just do what I do and just love doing it. For those just joining us, my name's Johnny, and I've been a professional software engineer for 14 years now. In this series, we're on an ambitious journey to build not only a fully fledged business, but a production-level application called Klipshow. Klipshow is an application that came out of necessity when I started streaming almost a year ago. I wanted the ability to be able to trigger clips on my iPad or on my phone and have it display on stream, because a lot of the times there's no one in the stream and it can be kind of boring. So I felt like, if anything, it would be something that I would use, and I'm really hoping that other streamers will get benefit from it as well. Now, episode 7 is what I'm calling our mega episode, and I think we've really earned it. As you can see already, the episode is already the longest in the series at over 2 hours. In this episode, we crossed a major milestone, which allows for our viewers to now be able to redeem channel points in our stream, have those translate into Klipshow credits that they can go onto our Klipshow application for, show the profile for the streamer, and have that viewer redeem their Klipshow credits in the form of triggering these clip queues that we've been working on. It's so exciting, and we've already had some real users use it and find bugs, and it's getting to the point where this is feeling like a real application that we can start putting in front of other people, and they can rely on it. We also integrated Solid Queue for the very first time, which went relatively smooth. So far, I'm very happy with how that's working. We also integrated the Mission Control gem, which is the UI interface to be able to see any of your failed jobs or your recurring tasks. And it's nice to be able to look at those, particularly for the debugging process when we were originally getting our first job working that handles creating, updating, and deleting Twitch channel rewards for a logged in streamer. In this episode, we leveraged Turbo a lot. We used Turbo and Turbo Streams for all of the functionality needed to create, read, update, and destroy the channel rewards for a streamer. And it was my first time leveraging only Turbo for that. We used no React for any of that. And don't worry to any of my React fans out there. We still use plenty of React in this episode, and we're not abandoning it. It just affirms that the approach that we took with a kind of a hybrid environment is working really well, and you'll get to see that in this episode. Before we dive into the episode, though, I do want to remind you that we have a free Discord community where all of my coders and gamers alike can hang out and chat with us. I try to keep my DMs as open as much as I can to answer any questions that anybody has. So go look in the description for that invite there and join our great growing community. And I also stream every single day on twitch.tv/oddjob. I streamed all of episode 7, and you get to see all of the kerfuffles and a lot more than just what's in this episode of the work that it took to get to this point. So if you're interested in that, head over to Twitch right now and drop us a follow so that you'll catch us for the next live broadcast. All right, without further ado, let's get into the episode because we've got a lot of ground to cover. Episode 6 left us in a great position to start building out some end-user functionality for Klipshow. And the reason that we're prioritizing this now is we've proven part of our proof of concept for displaying clips on stream. We're able to use that. The tech stack so far is holding up. So the next kind of evolution I'm feeling is having our viewers be able to trigger these, because that's where I think it's really going to be cool from the streamer's point of view to have these triggered from the viewer's point of view. So a few things that immediately come to mind that we're going to need to do is come up with a URL scheme that is going to be consistent and predictable and all of that kind of thing. So I'm thinking we'll follow a similar convention to YouTube. So to have somebody actually go to your Klipshow profile for a streamer, it will go klipshow.io/ in my case @oddjob, something like that. And that's similar to what YouTube will have in place. And this will allow the viewer to be able to get linked to there, and where the viewer will then be presented with the ability for them to sign in to their Klipshow account with Twitch and to see all of the clips that the streamer has available to play, and then ultimately to play them. And once we get that functionality done, I want to start looking into making the clips a little bit more dynamic and being able to have the viewer or the streamer change the size of the clip, the positioning, and that kind of thing. I think that'll be really cool. And then that should segue really nicely into tying clips together. So we mentioned, I think even in episode 1, that we want to have an entire show, or an entire presentation, maybe even is a good way to put it, of clips showing back to back, and they could be a sequence that you save. A sequence is probably a better phrase for it there. So a sequence of clips that we can use to have either just like as a one-time thing or something that the viewer can save on their account for that streamer and then play it multiple times. That would be cool. Another feature that we'll want to bake in is the ability for viewers to suggest social media clips that they want to have played, and then on the streamer side of things, we'll have the ability to approve it one time and or approve it and add it to their own Klipshow library so that they can play it themselves and other viewers can play it if they want. And I'm just thinking of all sorts of things that we can expand on at that point. But once we get the functionality to the point where the Twitch extension is working and this public profile is working, we know that we'll be able to have both sets of functionality that we can have presented to our ideal customer profile, which will be streamers and that kind of thing. So that'll be really exciting to see and start to really test the viability of Klipshow beyond just kind of our side project desires. So the first thing that we're going to do here, I think, is set up a streamer profile here that they can get to. This will ensure that whether the viewer is trying to get to this from mobile or whatever, they can get to it directly. I'm thinking we'll use Stripe Connect to accept payments in exchange for Klipshow credits. That's another thing that we'll be working on as well, is developing a Klipshow credit system that viewers can have and can be associated to each individual streamer. So having control over the flow of that transaction is nice. And then to complement that, I'm hopefully going to be still in compliant with the Twitch extension privacy policy and terms of use and all that kind of thing by allowing the ability for viewers to have Klipshow credits redeemed for bits, which is the Twitch-specific currency that streamers can get paid actual money for. And there's an exchange rate of about 10%. So if you're thinking $10, you'll get about $9 in usable bits, right? So that's how that would work. I think being able to handle it from both would be great. We'll be able to capture a small fee for both transactions, whether it's happening in the extension or in the browser. And that's going to be a great business opportunity for our free accounts. And I'm already thinking of features that we can have as a part of a premium Klipshow subscription for users that, like power users and that kind of thing. But I really want to keep the barrier to entry low for Klipshow, and having it be free immediately, I think, is the lowest barrier that we can have. And it still provides opportunities for us to monetize in the form of small transaction fees, which is a business model that I've always really wanted to expand on and have work. It's a really fascinating kind of concept. So we're going to get this started here. I just wanted to go over kind of my thoughts on that so that you can see from just fresh off of episode 6 where we stand and what we'll need to be focusing on next. So as we make progress here, I will go ahead and update the video. Sit tight. Moving things right along here, we've got a very basic proof of concept set up here for our @ kind of URL scheme here that we're going to use. We have this at the bottom of the routes file here. And basically, we're going to declare that anything following an @ will be treated as a display name being in the params. And we are going to route that to our new streamer profile controller. And the reason we're going to have this as its own controller instead of namespacing it off of another streamer controller is that the context for this will be different for those other controllers, namely the authentication. So we're going to very quickly get into needing to authenticate viewers for the purposes of how they're going to interact with streamers and that kind of thing. And so this will be the first step in that. They're not going to have any authentication to get to a user's profile, but in order to purchase Klipshow credits or to trigger a clip, they will need to sign in, and then from then on, they'll be treated as a viewer, even if they're signed in under a streamer user account. will need to account for that as well, making sure that no matter what their origination was in that single table inheritance kind of setups that we have, that they're treated as a viewer in the situations that they need to be. So we have our new streamer profile controller added here. So far, it's just very bare bones. We're just having one before action set up, and we're doing some validation to make sure that there is a display name in the params there captured by our routes declaration. If not, we'll redirect to just our sign-in page for now and show an alert message. And we're just doing this inline here to satisfy Rubocop, and I think that's a little cleaner anyway. I think this actually, this kind of contradicts right here, but it is what it is. If Rubocop doesn't complain, we won't say anything. But we're basically setting current streamer to the whatever the result is of the streamer that we may have in the database for the display name. So this will be set to lowercase when we search for it, and we'll make sure that it's downcase as well. So this should handle inconsistencies in characters, which I'm not sure how Twitch handles. I think it's kind of the same thing when it comes to authorization. I don't think just because you have a capital letter means that you can have that same name. I don't think. So we'll treat that so far as if that's the case. And if we need to pivot, of course, we will. But for now, this is just to kind of prove that that URL scheme works. We can get it set up in its own controller, its own layout, and we'll start to build out what we'll need to have the user presented with. So to prove that this is working here, I went to, I have a streamer record in file in the database for oddjob, and we're basically just doing localhost /@oddjob, and it's rendering our show view, which I didn't go over, but it is relatively simple. We just have a streamer profile folder here, a show file, or a show.html.erb to be precise, and then we're just making sure that the view can render, and then we have access to this instance variable. So from here, we will need to have a new layout added for just these kind of unauthenticated or viewer layout streams. So I think that is going to be the best way to do that, is to have a separate layout for the profile, and we'll start to work on that, and hopefully we'll get a good V1 that we can be testing and all that kind of stuff. So far, so good. This approach seems to be good so far, and I'll update it as we make more progress. We're making great progress on getting the public profile set up, and what I've basically accomplished up until this point is we have taken this entire component in the streamer dashboard that shows the currently playing, the queue, and all of the clips that can be played, and created a Rails partial so that this can be rendered in both this view and in the public profile view. And then we switched up our imports a little bit to be a little more systematic with what we're doing. So we did have the clips queues under the streamers dashboard clips, and I moved that out to be streamers as our subject, and then shared between the streamer profile and the streamer dashboard is my thinking behind that. Same thing with the TikTok preview, because we want the same thing available in the profile view, which is a completely different context inside the subject of streamers. So this is the scheme that we're following here, and we just basically changed up our imports to reflect that. And I did have a weird issue at some point in working on the Kamal deployment stuff. I think we overwrote the Anycable host here for our Docker file, and this was 0.0.0.0, which is incorrect. I'm not entirely sure exactly why, but you have to switch this to a local host, and I'm guessing it has a security measure to do in Chrome to not be able to bind on that port or something. I'm not sure. So yeah, we basically had to fix that, unrelated to what it is that we're working on here. But the idea is that we'll have that component in from our dashboard used both here, and then have all of the functionality, including that real-time functionality, on the streamer's profile. So what we're working with for that is what we have here. So I've added our Klipshow logo. My wife Daisy made this for us, so this looks great and makes us look a little more professional for sure. So shout out Daisy. And we're basically just showing the streamer's profile image here, a generic description for now, their display name, and then the credit system hasn't been built out yet. So I just put a placeholder here to show the current credits that they have for this streamer, and then a button to add more, which they'll be able to do with a credit card if they're doing it from this portal here. So we were able to render this partial out, and it is the exact same partial that's being rendered in the dashboard. So we moved this into the views shared folder, and this is under the streamer clip queues file. So this just takes the exact markup that was in the dashboard and changes it here. Now we are doing a clip's title here because we want that title to show differently based on the dashboard or in the public profile. So we made that a little bit dynamic. And then we're actually referencing them in the view. So where all that markup was here in the streamer clip queues index.html, we now just have this partial that's being rendered, and we have the same thing in our profile show. We're rendering that underneath the profile specific markup there. So we're able to reuse that, which is phenomenal. And then if we look inside of this partial, we're calling a few different methods and instance variables. So we have streamer clip queues. The action cable URL, this is actually going to change because this is assuming that we have access to update streamer clip queues, and we're using that streamer token in order to authorize that. So in the profile, we're going to need to change that, which we haven't done yet, but that's taking that as well. And then the other method is streamer clips, and I think that's it. So within the profile controller that we have here, we just have this in streamer profile controller. We're including that streamer clip queuable concern that we went over, I believe, in episode 5. And in that concern here, we set up a helper method for the streamer clips. The streamer clips will use the instance variable at current streamer and will include the streamer clips that are needed for that. From the context of this controller, we're setting up a before action that sets this streamer. And since we're having to set that based on the display name, we have to cast this to lowercase so that we can do an equal search in the database, so that we went over that just earlier. And we can prevent the rest of this flow from continuing if we don't declare a valid display name in the URL, and that will prevent that. If that passes, we just set the current streamer. We need this in a helper method because this is what our partial uses here. I believe current streamer right here. So where we're getting that alert token here, we're calling current streamer. That method is being exposed with a helper method from the controller here. And so that's how that works. Helper methods can be used inside the view itself that are scoped to the same view, right? So this is streamer profile controller, and this is the streamer clips queue partial, but it's being rendered within the show page of this controller. So kind of complicated, but it's nice to abstract that and be able to reuse these components like this. And we can do that by setting up different scopes. There's different ways that we set current streamer here versus in the other use of it where it originally came from. So if we have both this tab open and this tab here, and if everything is hooked up to Anycable and they're both subscribed to the real-time events, we should see these queues load up in both views here. So in the streamer dashboard and in the top here, or in the profile rather. So I didn't update this, it updated in the background because they're both listening. So the next thing that we need to do is limit these skip and clear queue buttons here, because from the viewer's perspective, they only can see this. They're not going to be able to have access to skip a clip or pause or anything like that. So we're going to have to set up some conditioning logic to prevent that in the instance or scenario of the viewer looking at this page. And that will also tie into limiting how we're authenticating this side of the viewers to make sure that from our controller logic, we know that this is a viewer and we need to scope all of the permissions accordingly and not let any destructive actions be permissible to whatever we are exposing to the profile here. So that'll be the next step, but I just wanted to check in and give an update. After that, we'll start to dive into what the Klipshow credit system is going to look like and my thoughts on that. And we're going to hopefully figure out a happy medium between purchasing them with a credit card and channel points that you can redeem within Twitch, and then this will also be the same credits that you'll be able to redeem for bits inside of the Twitch extension. And we might run into some terms of use issues there, I'm not sure, but we'll be cognizant of that and make sure to be on the lookout. But either way, we'll be able to rely on this, and if we can't accept bits, then we will just have to use this as a fallback. So just thinking out loud there and checking in. This is great progress, and this is looking great. Oh, another thing that is worth mentioning, I asked Claude to generate a mock-up for us that we could go off of, and it didn't have the context from the original mock-up because I exited out of that chat because the context window was getting too large. But this is where this came from, and this is where I really struggle with stuff, is just trying to put something together that looks well manicured and stuff like that. So although it's not a one-to-one, it is what I based my inspiration off of here, and to try to get out of that writer's block. So we're just using the same kind of colors and themes and adding this new kind of green. I'm not sure if that's aesthetically sound, but it looks okay to me for now. And yeah, but I just wanted to mention that it's another great use of our AI tools that we have access to now. So any other call outs that I can come up with, I'll include it. Until then, I'm going to make some progress on coming up with a strategy for the permissions around this stuff and the viewer-based authentication. So I will check back in just a moment. Okay, so we should have a solution in place here for the scoped connections and being able to find a streamer based off of that alert token that's passed in that is going to be treated as privileged, or just their display name. So ultimately, the general public can get connected to a streamer's clip queue, and that's just a side effect of having the service available. So we just, in that case, need public available information. We're not just giving anybody the ability to connect just based off a list or something like that. You still have to at least know their display name to find the streamer record in the database. And so we're just changing our authentication here a little bit to either find it by that alert token, which we'll use for the alert consumer in OBS, or if it's just a regular anonymous subscriber, we can find the streamer that we need to have scoped to this connection by their display name. And then if we can't find either, we'll reject it as an unauthorized connection. So there's still a little layer of prevention for being able to have multiple connections that shouldn't be there and stuff like that. So that's at the crux there. And then inside of our streamer clips queues partial and inside of the React component, we're passing in another prop here for privileged, and this is just basically preventing the UI elements on the page from showing, because that's what ultimately allows them to have control over that. And when the pause button, for example, is clicked, it will run this method here, and ksfetch will run based on the CSRF token that is in the header, and that token is not going to be available on the public profile because it's not an authenticated endpoint. So by just preventing the UI source, even if they were to look and see these endpoints and that we can access this, they will still be unauthorized because of that CSRF token that we're going to check and being able to pull the streamer out of that. They also won't have the cookies, more specifically, that would need to be included with this request in order to decrypt the controllers, the OAuth flow, that token that gets set in cookies, that needs to be sent over the wire, encrypted, and signed. So again, that will prevent general access to this, even though they'll be able to see the component that the streamer uses. So what we're left with is the queues looking like this. We have the add to queue functions here, which we haven't messed with yet. We're going to need to add another action for the clip card here based on the profile interaction, because they won't be able to add to the queue directly. They'll have to go through and utilize their credits, and we'll have to tweak this component to reflect how many credits it takes to actually add this to the queue. So we have this working now. This is confirmed. We have in this streamer dashboard here, we have that privileged flag set to true. And once we go to clear the queue, for example, it works as expected, and we're synchronizing on both states. So this is really exciting stuff. And the next thing that we'll need to do is just building out this stuff here and the credit system. So I think this is where I'll spend a little time getting the design going, and then we'll break that down and implement the interaction with this here, and then that will be almost ready to start using in a practical way. I think the first thing that we'll need to do is get the channel point redemptions working within Twitch. And the reason I'm going to prioritize those is because that's a free way to get tokens. You're just basically exchanging time spent in the stream to be able to get those Klipshow credits. And that's a lower barrier to entry. And then for the more advanced users or more avid users or viewers, then they'll have the ability to support the stream by purchasing Klipshow credits. And how that is going to work is a percentage will go to the streamer and a percentage will go to Klipshow for our operation costs and that kind of thing. So it'll be exciting to try to figure that out and get a good kind of ratio going there and hopefully start getting people on the platform. In order to accomplish the functionality that we need for our credit system, here's what I'm thinking. Instead of having individual records for credits that we use to have both an audit trail and a current sum of what their credits are, I'm thinking we use like this wallet and transaction approach. I was using Cursor to discuss this and to kind of brainstorm ideas, and asking it questions and having it write some pseudocode for me helped me come to this conclusion. And I think it's much better than a system that I've implemented in other projects recently where it's like an individual credit. One credit is one record in the database. Clearly, that's not going to scale well. So with this, we'll be able to encapsulate any size of the transaction with one row, whether it be one credit or a million credits. The balance will be reflected in one transaction. So my thinking is we'll get the request from either Twitch or Stripe, for example, since we're going to implement Stripe Connect and allow these credits to be activated with a credit card. Whenever that transaction occurs, we'll have a service that will have monitor and create this, be the middleman between these two models. And it'll basically create a transaction. A transaction will be tied to whatever ID we can grab from here, along with any other metadata that we'll store in a JSON column. We'll store the source so we can tell that this came from Twitch or whatever. And then it's going to have a streamer wallet ID, and that's going to directly correlate with the streamer wallet record. And the streamer ID, viewer ID are the two foreign keys that we'll use to bridge this relationship here. So per streamer, in order to interact as a viewer with that streamer, you need to have credits with just their wallet. It's going to be specific to each streamer. So it's not going to be your credits don't carry from one streamer to another. It's another implementation detail that we have to get right. So I think this will accomplish that. We'll keep about a streamer wallet per streamer when a viewer interacts with them in the form of purchasing or redeeming credits. And then what will happen in this transaction service each time we go to create a transaction, whether it's a redemption or a top off, adding credits to the wallet, we'll need to make sure that the balances are accounted for and updated in real time on the actual wallet itself. This will ultimately allow us to just have to load one record in the database to get the underlying balance, which is what we need. The other system that I have would need to sum the value of credits that are in a database. And again, that's not very efficient. This should hopefully work better in that way, in that we're able to capture both an audit trail and have one record keep track of our balance that we're able to use for all of the transactions that take place. So we'll have all this bridged in a transaction service, and this how these two models will actually relate to one another. In the migration to add this here, we're just going to have both tables created in a single migration. And the more I think about it, I think I want this to be a float and for this to be a float, and I'll have to drop the database. But again, we're not in the middle of two different commits, so we'll be able to get away with this. At any rate, the streamer wallets table will hold the references for the streamer and the viewer. These will be the foreign keys that ultimately map to that user table, but we're using this nomenclature here to know the difference in how they're treated, right? So that will be the references for that. And then the balance will be a float, and the float will allow us to do fractional transactions if we ever decide to support that. In the streamer wallet transactions table there, I had a transaction ID, but I think we'll use the ID that will get generated in the table automatically for our unique ID for each transaction. And then if we need to store any kind of transaction ID from Twitch or Stripe, I think it would be more fitting to do it in the metadata column. And I'll omit using any kind of index here, although Postgres does support JSON binary column type indexing pretty well. I don't think we'll need to look it up by those transaction types. I think it will just be more for our audit trail. So this is what those migrations look like. And then in the actual models, very simple. We just have a simple has many relationship set up between streamer wallet and the streamer transactions, making sure that we're mapping them to the correct class name so that we can access them as transactions. And then on the streamer wallet transaction class, it's even more plain by just setting up a belongs to. It's just a one-to-many relationship. And then we're validating that there's a source, an amount on there, and then the actual service itself, the service that we'll use to actually generate these will be very simple as well. We'll just pass it that streamer wallet, source, amount, and metadata, and we will create a transaction based on that. And since we're using this transaction style and having it kept up to date with another record, we need to be cognizant of making sure that the database row for that streamer wallet stays locked so that we're not getting a balance on the streamer wallet that is actually incorrect. So we'll set up the active record interface for this is very simple. We'll just do the instance of streamer wallet will get locked, and what this will do is wrap our block in a transaction that will fail if it's either unable to obtain a lock or if there's already another transaction or if the transaction fails altogether. So what we're trying to accomplish with this is making sure that when a transaction is created, it will make sure it's basing the balance change on the streamer wallet's balance at that point in time. Yo, Tortoise, what is up, dude? So the with lock here is important to make note of, and we found this in the active record documentation here. They're actually showing this in a similar kind of example with trying to update transactions and that kind of thing. So it goes over what the lock is actually doing under the hood and why you have to have it inside of a transaction, and then ultimately led us to, from an instance of a model, we can use this with lock method to accomplish both the transaction and being able to pass in a lock just to that row. We don't need the entire table locked. Other streamer wallets balances can get checked, but this one in particular, since we're operating on it, needs to be locked so that in the order we receive these transactions, the balance will be updated accordingly. So the streamer wallet transaction service, the only thing that we have it doing right now is that lock, and then we're also making sure that the balance can never be less than 0. So in this case here, there's no credits ever, there's no refunds. The system's not taking any of that into account. So it will test, or it will check to see if the amount that we are trying to create a transaction for will leave the streamer wallet balance at 0 or less than 0 rather, and if it will raise an insufficient balance standard error. So our specifications for this are pretty straightforward. We just have a specification testing the create method both in a situation that succeeds and raises an error, and we also have model specs that test the validations and the associations. Pretty standard stuff there. The next thing that we'll need to build out is an interface inside of the Klipshow dashboard to allow for streamers to set up channel point redemptions being used in Klipshow. So the process for that, as you'll see, is going to require an interface for the streamer to be able to show their channel points and to link the channel point that they want to the correct one. And then we'll ultimately need to make sure that we make the API call to Twitch to subscribe to the webhook when those specific channel point redemptions are redeemed, and then we can implement the logic here of adding to whatever viewer it is, and that kind of thing. So that will be the next thing that we work on. And since we have a good working knowledge of V1 of the bones of this kind of system, we should be able to move forward and have it actually working here pretty soon. Since we're able to have channel points generated for free, we can play with that and create kind of a still a authenticated source for these credits. We're not just releasing it to any viewer or anything like that. It still will only be able to be redeemed through channel point redemptions, and then after that we'll be able to integrate the Stripe Connect, and then we'll be able to do that as well. And we may even implement a interface for streamers to be able to gift viewers tokens as well, or credits in this case as well. So a lot of fun stuff that we'll be able to implement here, and this is at the crux of it. So trying to keep it simple, trying to keep it straightforward, and document my thought process along the way, so that if we do decide to change everything, at least you'll know kind of how I came to that conclusion. So I'm going to go back to heads down and build out some of this functionality for being able to create these transactions in a controller or something that can have a request from the outside world. In this case here, it'll be a Twitch webhook, and we'll get all that set up next. The first source that we'll be able to create Klipshow credits from will be the channel point redemptions mechanism in Twitch. For those of you not familiar with Twitch, channel points are something that you can accrue with a streamer by spending time in their channel. You accrue these points, and then the streamer creates rewards that the viewers can use to redeem those points. And Twitch allows for us to access this mechanism via the API, and we should be able to create channel point redemptions on the streamer's behalf. And the reason that that's going to be important to do is so we can subsequently set up an associated webhook with that redemption, so that when that redemption gets redeemed by a streamer's viewer, Klipshow will be notified and will actually be able to have the transaction made to reflect the change in balance for whatever viewer is redeeming that channel point. So the first thing that we did here is we're creating a settings section in Klipshow now, and we're going to have this experience be in this settings page. And my thinking on this is we'll have the ability for streamers to create at least one channel point redemption, and we'll be able to have a record in the database stored attached to that streamer, so that we can load those redemptions, and if there's any changes that we may want to support in the future, like increasing or decreasing the cost of the channel point redemption, I think we can do that as well. And just for displaying the channel point redemption themselves, we're going to need to have that stored in the database. So we're going to create a new model to track that and associate it to the streamer, as well as create the form and all of the actions that we'll need in this new settings view. In the page where the streamer will be able to create and edit and delete these redemptions, we'll list all of those records, and we'll also implement, for the first time, a background job. And that's going to require us making sure that our solid queue configuration is set up. And for those of you not familiar with background jobs and kind of how those work just in general or in Ruby, it's essentially a process that serves a purpose for not serving web requests, but instead carrying out tasks that we write in Ruby labeled as jobs. And those run separate from the service that will have actually processing the web requests for the application itself. Normally, what I reach for this is the tried and true method of using Redis along with a gem called Sidekick to manage all of that. And normally that works very well, scales very nicely, everything just kind of works out of the box. But because we're trying to explore these new Rails features and cut down on our dependencies, we're going the solid queue route, which instead of using Redis as the management of storing the job information that is needed to carry out whatever job is running, we'll be using the same Postgres database that we're using for the rest of our user information and everything else, all those other models that we have in Klipshow. It'll be under a separate database name, but it'll be the same database server. So I've never used this system before, but it should work pretty well. And ultimately, once we get the kinks worked out, it will leave us with a robust active job-backed job processing system that doesn't rely on Redis or Sidekick for that matter. I went ahead and created a migration for those records we'll need to store in the database associating the Twitch channel point redemption to the streamers. So we're creating a table here called Twitch channel redemptions, and I'm just setting up a basic system here for the streamer references. This sets up the foreign keys to associate each row to a streamer. And then the rest of it is pretty self-explanatory here. We will have a status column, and this is how we'll track the process in this channel point redemption. I'm trying to make this something that can run and can be a bit resilient in the case that it needs to either rerun or something like that. And the reason for that is we're coordinating with an external service, Twitch in this case, and there are a few different things that can go wrong in that situation. A bad API request or a timeout, or maybe Twitch's API is down, something like that. And so by keeping our own internal tracking system for these individual items will not only provide a better experience for the user, the streamer in this case, as they'll have a better idea of what's actually going on. If it goes from pending to active and that just kind of happens, there's kind of already an understanding there that something just happened behind the scenes to set this up. So we'll have that aspect of it, and then for the aspect of keeping things clean and making sure that if a channel redemption is in the status of active, for example, that only happens if we should have the redemption created with the right settings that the streamer will configure, and also has that webhook subscribed to on Twitch's end so that Klipshow can actually create those transactions for Klipshow credits. So in the routes here, we have our streamer settings that we just declared, and we're calling that streamer settings as the alias, and then we are creating a controller called streamer settings controller that is where we'll house this functionality. We're also creating a resources declaration around this for our new Twitch channel point redemptions, or excuse me, Twitch channel redemptions, trying to keep it, specific to Twitch, but still vague enough to be their reward system and not like a point system or something. Anyway, that was the name that I chose. And we're declaring the path here to try to keep it a little organized so that it's just /settings in the browser for that. Pretty standard there. In our channel redemption model here, we're just declaring that it belongs to a streamer, and we're validating these columns to make sure that they're present and they have a numericality that is at least greater than 0. So this is just setting up some basic validations for when we receive these. What we're going to do is rely on this model to give us the information we need to create a transaction, which will ultimately affect the viewer's balance. And something that's just dawning on me is we're going to have to figure out at some point in this process creating a account in Klipshow for the viewer when these channel points get redeemed, because we're going to need a viewer record to associate these Klipshow credit transactions to in order to have that balance reflected accurately when those viewers go to redeem their credits and that kind of thing. So we'll figure that as we go, but kind of the meat and potatoes here of just getting this model system working so that we can have kind of a CRUD experience in this new settings view that we can then associate to a background job, which will make responsible for the calls to Twitch to either get the user's info. If there's not a record and file, hopefully we'll be able to do that. If not, we'll figure out a way around it, and to ultimately set up that webhook and the redemptions and stuff. So there's going to be a few API calls there that all need to work in order for the functionality tied to creating these records in the settings to function as we intended to. In our settings show view here, it's set up very similar using the content for block in order to change the content of the heading in the dashboard. And then we're just setting up a card here and a few Tailwind styles. There's a link here in a turbo frame, and this is kind of where the exciting part is here. Instead of using a React component for this, I figured this would be a great use case for going the approach of using turbo frames and turbo streams in this example. And the reason I felt good to do that was we didn't really need any JavaScript interaction with the form input fields. We could have some dynamic validations happen there, which would be nicer and easier to deal with in a React component, in my opinion, but there's more moving parts to make that work. And so the reason we took the approach of having both React and Hotwire at our disposal is we can pick which one makes the most sense. In the case of being able to navigate around our application, specifically in the dashboard, as that's mainly what we've built out, the navigation is a nice trade out to have instead of something like React Router, because we can have our nice sidebar to the left and all of our content loads, and that just kind of works, right? We had to do a little bit of wiring with the event listeners to make sure that the React components rendered when those turbo frames load out. But other than that, it works nicer, in my opinion, than what React Router would be. So that's a win there. In certain situations, like the queuing system, where there's a lot of dynamic functionality, in my mind, it makes sense to just have that in React to keep it easy to handle the state management. We created a custom hook that uses the Anycable subscription to keep the collection synced on both the front end and back end. That works phenomenally well. And you'll see here, as I've already built out a lot of this functionality, that there's a lot of extra steps with going the TurboStream approach. And although it may feel more home to Rails, so far I'm not seeing a great trade-off for the benefit in using all of this. We're using a lot of different things to make it work. And although I think it's working well in this case, and we'll go over that in just a few moments, I'm reflecting on it now, and it seems like we're not really gaining anything by using this over something like a React component. You can argue that having just HTML load on the page is a little bit more stable in the event that an error or something gets raised in the React component. In that case, the React component won't render, and there will be nothing on the screen. That is a benefit of using this approach here. Is we're using a more primitive HTML approach. So if the HTML looks right in one view, as long as you have a network connection to get the next view to swap out, it should just work as you expect. So that's a win for Turbo, and it's not all bad. It's just I'm trying to find that balance between what makes sense between the two. And on this decision here, I'm glad that we went with it because it's a great use case for us to go off of. But having the information that I have now, I'm not super sure I would go this approach again. So we'll keep an open mind to it though, and you'll see kind of what I mean as we go through all of this and kind of how the solution that at least I have in place now was a little bit more intricate than maybe it needed to be. So we have two different turbo frames that we're loading here. One for the actual form that will render in a separate view to create these redemptions, and then another view to show the table of redemptions that are stored and all of that kind of thing. So there are two different frames that we have here that are being used for that functionality, and we'll have some other functionality we'll need to introduce turbo streams for in a moment. But the most exciting thing on this view here are the two different turbo frames, one that we'll use for the form, and then one to use the actual table to render each of the Klipshow components. So in our settings page here, we've added a link to the settings view in our navigation, and this is rendering the view that we just went over. So by default, it will have no Twitch channel point redemptions, and we have this link here, which is this guy right here. And the reason that this is important is we are including this data attribute specifying which turbo frame the contents of this request needs to be swapped out. So we have our turbo frame with an ID of new Twitch channel redemption. That's this section in the DOM. And we're telling, by associating this attribute here, replace the contents of what you would get from this request in this frame here. So it's at the crux of what Turbo does. And you'll see here, when we click the new redemption, we have this new element on the page. And what's actually happening is Turbo is fetching that view, rendering it, and then replacing only the section in our page here that it needs to based on that attribute. So that's pretty cool. This is the first iteration of that. We may change this to be something more along the lines of what I would do and what would be a little bit easier potentially in React, which is just having a entry here in the table with blank fields that you can fill out all in a line. As you can see, this kind of takes up a lot of space, and it gives you a perfect idea of what it is that you're trying to do. Maybe not a perfect idea, but hopefully a good idea of what you're trying to do. Create a Twitch channel point redemption with the title, description, the Klipshow credits associated to it, and the cost that will be needed to redeem it. So hopefully that will work, and the workings behind it are leveraging Turbo, and we'll go ahead and create a new one here. Okay, so I just filled this out, just some generic information here. And when we click the Create button, we can look in this form here that's actually rendering in our new our new view for the channel point redemption. So this is coming from the Twitch channel redemptions resources routes that we're defining in our routes.rb. And then it's just using the same convention for what we're using for any other form, really. So this is a very basic view. It has a turbo frame. It's the same frame ID as what we have before. And I'll have to, thinking about it now, I'm not sure if that's the right way to do it. I'm still trying to get these turbo like replace versus update and that kind of thing done. But this is working now to the best of my knowledge. So I'll explain it to the best that I know how. And then if I find that this isn't the right way, I'll be sure to give a call out for it. But in here, we're just rendering a form that I was going to use to edit the redemptions, but we ended up using this inline form instead, and we'll go over that. But in the form, we're using the form4 method, passing in that Twitch channel redemption, which we're getting as a locale from where we're rendering this partial. The URL is coming from what's declared in routes. And then the important part here is that we're passing in a similar, it's actually the exact same attribute, data turbo frame here. And what this is doing is saying the response that is sent from the form should replace this turbo frame here. So this is what's handling the ability to show any errors. If there's any active record errors on this model when we go to save it. So instead of having inline validations, we're using the kind of traditional Rails way of using active record and a bulleted list to show that there's errors in the new form here to make sure that the data that we're getting is accurate and everything like that. And we'll be able to see when we click create that we have some bugs to fix here, but it is creating a, it's showing our channel point redemption here. And if we refresh the page, it is actually showing what it should show when we create the form. I'll have to go through, and probably that turbo frame is the wrong, it's having two turbo frames nested inside of each other, which is probably wrong. So that's probably what the issue is with that. But this is what it looks like when it's working normally. And we're going to create a heading here. I think looking at it now, it would make sense to have like a description, title, channel points, credits, and then status. And then from here, you can click edit, and then it renders. I did have this aligned better. We'll have to work on that. And this isn't the most pretty, but you get the idea. It's an inline form at this point that you can just kind of edit here. And I believe this is working. So if we wanted to up the channel points, for example, we can do that. Redemption updated, and it shows as reflected here. So there's actually a lot going on. As you just saw, there was a bug when we create one initially, and that should be easily fixed. We're proving the concept here, at the very least, that we're understanding the intended purpose behind the turbo frames and that kind of thing. So that is creating one initially. And as you notice, the toast message that we normally have pop up after like an AJAX request or what we have in the clip library section that we went over in a much earlier episode, the toast message shows up there. And the reason I'm calling that out is because using this approach with having this be a turbo frame that updates and saves and everything, in order to have that toast message appear, we had to get a little creative and track down how to create a custom turbo stream action. And this is the first exposure to a turbo stream that Klipshow has had. And a turbo stream is almost like, from my understanding of it thus far, a set of instructions on what to do with the response that's being rendered to manipulate the DOM. And what this allows us to do is trigger certain elements to be replaced in the DOM. So in the example here of updating this, when we go and save it, the turbo stream that is being responded to instructs turbo or hotwire, however you want to look at it, to replace this component in the DOM. And it does that based on the unique ID that is associated upon the creation of this record. We can go into the inner workings of that now. So we have a item partial here that we're rendering from the show view for our settings. And basically this gets rendered as a partial with some locals set to it. And we are rendering this in each row when an item is created, and this is also what will get rendered. Well, actually, excuse me, I was going to say this also gets rendered when we click edit, but that's not true. The edit will actually go to this partial, and the edit button is the little icon here. When we click edit, this is a completely different view. It's our edit view, and we're trying to just render the inline form the same as hopefully we'll be able to kind of set this up to have for both new records and existing records. But for now, this is how this is working. It's a separate view altogether that shows inline. And then the inline form here, there's two different forms because, again, the kind of trying to just get it working versus getting it working as intended in kind of like a row manner. But it's essentially the same thing. It may look like there's more going on. The biggest thing to pay attention to is that instead of just having a static ID here, we are interpolating the ID from the model that's getting created in the database. And this is what allows us to target that specific element on the DOM for the update actions and that kind of thing. So we're handling errors in a very similar way here by just checking for it on the actual record itself. And we're having the response from this form being updated, having it update the turbo frame with the corresponding ID, which will ultimately update the item here, because this is where the turbo frame kind of starts. And then when we actually update from the form in our Twitch channel redemptions controller here, we have just some basic CRUD setup. Just create that edit for that edit view, and then update for updating an existing record. And the magic that's happening here, in order to update the record in the table and to show the toast message based on if the redemption was properly updated or if there's errors, we have to respond with a turbo stream. So this is the first time that we have used this in Klipshow here. And what we're doing in the action for both the create and update is specifying that we can respond to the turbo stream type response format here. And by doing that, we can instruct Rails to render the turbo stream view. It's essentially like XML, if you can think of it like that. It's like instructions for turbo to update the page and to carry out whatever it needs to do after this action has been performed, right? So the big thing to note here is just the turbo stream response. We're rendering that view, and in order to have that render properly, the scheme that you have to follow here is the action.turbostream.erb. So in the case of the update turbo action here, when we're using that inline form, the turbo stream replace action is what we're using, and it's a Rails helper method to generate the markup needed for that XML style kind of instruction set that makes up a turbo stream. So we're replacing the contents of what is currently on the DOM with this here. We're actually replacing the element altogether with replace, and then update would subsequently just replace the inner HTML, from my understanding. And again, we're interpolating the unique ID that is associated to that record, and then just having it replace that with that same partial. So it will re-render that view, replace it with the new data, and insert it into the DOM. The only other thing that we have going on here is a new turbo stream that I had to create for making sure that in this situation here where the turbo frames are getting reloaded, we're able to hook into that and show any toast messages that may be returned from the controller. You can see here in the controller for the update action, we're setting the flash notice message to redemption updated only for the turbo stream responses. So this makes those flash messages available in our views, but we have to re-render the toast component in order to actually have it display. So inside this shared turbo update toast action that we have, we're just using a turbo stream action tag, and what this does is help you generate the markup needed to declare a custom toast action, just like we're using turbostream.replace. We want to call a custom action that we can associate to our React component that handles the toast messages, and that ultimately is what gets the contents of the flash message to be displayed on the screen as you see it. So we're declaring a custom action here called show toast, and then since this is an ERB view, we have access to the flash.now, and we're just passing that in as attributes in the XML that will get generated as this. It'll generate something like this, like turbo stream action replace, something like that is what will actually get rendered as a result of using this Rails helper method here. And then in our React component for rendering the toast actions, we're able to import the stream actions module from Hotwired Turbo, and this is where we actually define this function here. So we call stream actions.showToast. In this case here, it's showToast because this is what we're referring to it as in what is going to be generated as the turbo stream. And then we're using a function here, and it's important to call this out. We're not using an arrow function here because an arrow function will change the context of this in order to preserve it for other use. In this case here, we need this keyword to associate to the constructor that is being associated with our custom function here. The reason for that is, according to the TurboStream documentation, this is the convention used to get those attributes out of the TurboStream tag and be able to use it in our toast message here. So we're able to, by using a regular function, we're able to declare our notice and alert messages. We just have this set up to be either or. And if one of them is present in this element here when this is called, we will call our handle toast event function, which is the same thing that we're calling for all of the other uses for it. This is just allowing us to tap into it in the event that we need to do it for a custom turbo stream. So this is the solution that I came up with in order to preserve the functionality for our toast messages in any way that it can be displayed on the app, whether it be through a regular Hotwire form or a React component making an AJAX request. And so far, it seems to all be working together. So although there are more moving parts, and I think that's kind of what my gripe is with using turbo frames in this situation here, when we already have React that can handle state management in an easier way. There's a bit of a trade-off with just rendering HTML, and I get that, and so we'll ride that benefit, but these are just things to consider. Anytime that you're using a new technology, in my opinion, you should always be testing it and seeing if it's actually making your development lifecycle easier or if it's just another thing to say that you've put inside of an application. So the biggest things to call out here were the TurboStream tags and kind of illustrating how we're able to use a Rails helper method to just use a regular link and have that link replace a turbo frame in our DOM. That is great functionality, and it just works, and I love that. It's when we need to tap into the update action that it gets a little bit hairy, but overall it wasn't too terrible. I will continue to use this as I see fit. And again, my biggest reasoning for using this approach is that I didn't need anything fancy with our validation here in our inputs. We can rely on active record validations and use the Rails way of having this rendered to the viewer, or the user in this case, instead of needing anything like what we're doing with the form to submit a clip. It takes a TikTok URL, parses it, makes sure that the pattern matches, and then subsequently goes and loads that TikTok and make sure that it's valid. That's a lot more functionality that we need some JavaScript for. So in that example, it would make sense to just have the form work in React. But in a situation like this where it's less dynamic, I think we can lean on Turbo and make sure that we're familiar with it and have it in our arsenal to use when it makes sense. If you need to add solid queue manually, you can use the bundle add solid queue command. And then once you have the gem added to the gem file and installed, you can run the install generator with the Rails solid queue install command. And this is going to look very similar to the database.yaml. In fact, that's where we had to make most of our changes. One of the files that it makes for us is config/q.yaml. That file is here, and there's not a whole lot going on here yet, but this is where we can tune the dispatchers and the workers. So a dispatcher is just the task that's going to be responsible for fetching information that's stored in the database and passing it along to the worker, which will actually execute the jobs function. And this is the current configuration I have for development. So in database.yaml, you have to provide the development environment, and this is our primary database. And the reason we're setting it up this way is we're using the same database for both the primary database and the Q database. So it's essentially going to be the same database for now. We may change that later, but this is the current configuration that we have for that. We're basically setting the database name, and in the primary case, it's just our Klipshow development. And in the Q case, we have to add the primary development environment, which we're tagging here and specifying that it has a different database following the same nomenclature as everything else, just adding a _Q at the end of it. And then the migrations path again, this is just set by default, will be under db/qmigrate. I haven't run into any part of this process yet where I think I'm going to need to actually migrate one of the database here. I'm not sure how that works yet, so we'll get to that as we needed to. But this should be enough to go off of to at least get the bin rails job command running in the terminal here. But before you're able to do that, you have to run the rails db prepare command with all of this configuration set, and that will create this database and make sure that all of the migrations are run if there are any already in there, and get it set up to actually start processing jobs. So I haven't worked this into my Docker Compose file yet, but what we can run is we can run manually the Docker Compose exec command, and on our web instance, we should be able to start the active record, the solid job processing system, the actual runner, with this command here. So this is running in the context of our Docker web container instance, and it's actually running in the background. We don't have any logged output. To the best of my knowledge, that's normal, but it is running, I believe. And in order to, as I mentioned before, I normally use Sidekick, which comes by default with the ability to have a dashboard for monitoring your current jobs that are queued, any jobs that have failed, and that kind of thing. The solid queue gem doesn't come with that shipped out of the box, but Rails does have another gem called mission control that we can use. So the gem is called mission_control-jobs, and you add this to your gem file, run the bundle install to make sure that it actually gets installed, and then you can, in your routes file, you can mount this very similar to what you would do with Sidekick, and then it gives you a very simple, probably using something like Bootstrap or something like that, gives you access to that. It has a ability to lock down the dashboard for the solid queue stuff by using HTTP basic authentication, and you can define those credentials in your secrets file. So if we follow the README here, it will go over that. In order to change the credentials, the command for that is just editor vim. In my case, I'd be using vim for this, and then Rails credentials edit. And then you can also pass in the environment if you need to, which I will need to do when we get this into production. You'll set those up to in the production secrets, which is a separate section or a separate file, and you'll basically put the mission control section and then HTTP basic auth user. I just literally, for the dev environment, I just did the same thing here. In the production, if you're using the HTTP basic auth, you'll need to make sure to set those credentials in the production version of the secrets file. And it does mention somewhere that if you do not have the credentials here, that it will not mount the dashboard, or it won't complete the request, something like that. So make sure you at least have HTTP basic auth. There are a few ways that you can do that. The credentials is the default way of doing it, it looks like, and then you can also specify them in the in an initializer or something like that if you prefer. Okay, so with that set up, in our routes file, we've added the mount mission control jobs engine at /jobs. And with the environment running, if we go there, we'll receive the HTTP basic auth dialog here. We're going to put in dev and secret. And this looks like we have it set up. Now, this did not render right away for me when I very first added this. And the reason for that is we are running the Vite Rails gem. We're not using PropShaft, which is the default asset engine for Rails. This engine uses PropShaft, I believe. You have to use, PropShaft in order to compile the assets to make the dashboard for that work. So they are probably using just the modern day equivalent of the Sprockets kind of application CSS, and PropShaft is the new gem that compiles all of that. So you have to have that in your gem file, another gem that comes default with Rails. So I didn't need to add that. But if you're coming from a different configuration, you'll need to make sure that PropShaft is installed by default. And then it's important to run the Rails asset precompile in production environment, even though you're using it locally. And what that will do is generate those assets. And the reason we have to do it this way is because we're using this Vite Ruby gem instead of the default Rails asset way of kind of like putting things together. So the documentation does go over that, and you'll just need to keep that in mind if and when, since we're already doing this in our Docker file, the run secret this line right here. Since we're already doing this in our Docker file for our production builds, we shouldn't run into an issue with that, and the assets for mission control should still get compiled. If I run into issues, I'll be sure to call that out. And so this is as far as we've gotten so far. We've gotten active job set up, ready to work with Postgres in development, or at least it looks like it is. I haven't actually enqueued a job yet, but we've got a good idea of what we want to do here with our channel point redemptions and this kind of status column. And then we briefly discussed what's going to need to happen with these Twitch webhooks and getting the actual Klipshow credit transaction created so that the user can actually have credits to use in Klipshow. So we're set up nicely for this. I think the next steps is to make sure we have the proper setup for Turbo to be able to send over a Turbo stream live via the Anycable connection backend. And the reason for that is once one of these is saved, we'll want it to automatically update the status once that job that is processing this is finished. So that'll give a nice kind of real-time reaction to the this getting created, and hopefully it'll happen pretty quickly after creating it. And since we already have ActionCable hooked up and all of that stuff, it just makes sense to use this and give the user a little bit nicer experience for this kind of thing. So the next things that I will work on and figure out the logistics around are actually getting the channel point redemption created on Twitch's side, subsequently conditionally creating a new Klipshow account if the viewer that's redeeming the reward doesn't have an account with Klipshow yet. And we'll also set up setting up the webhook and the status update and the job itself. So I'll get heads down on that, and then if I run into anything worth mentioning, I'll bring the video back. If not, we'll do a little bit of a review once I have some more functionality sorted. Before we get started on figuring out what we need to be able to build this functionality, specifically to have these rewards created on the Twitch side of things, I like to refer to a diagram. A lot of the times I'll make these myself. I'm trying Claude here to create one, and it's not quite as detailed as I would have, but it should still illustrate what we need here. So basically, from the application, the streamer is going to create a reward, and in the backend, we're going to enqueue a job using SolidQ that we just got going, and that job is going to sit and prevent our web server or any other process from having a kind of locked situation where it can't handle web requests coming in or out for the application itself. And so that's why we're having it allocated to another task, another process, and that process is going to make an API call to Twitch on behalf of the streamer. If you remember, our authentication works with Twitch's OAuth API, and we're storing the access token on the streamer, and we've added some validation to make sure that the OAuth refresh expiration is not expired or about to expire before we allow the user to create this request on the settings view in the streamer dashboard. And the reason for that is we need to make sure that the OAuth refresh token can be refreshed, and we're only able to do that if the expiration on that hasn't lapsed yet. So we make sure that when a user creates a reward from the settings view, that we should have pretty good confidence that we have the token needed to make that call to Twitch on behalf of the streamer. Because what we're doing is actually creating a reward in the streamer's profile through this Twitch API, and that's all authenticated through the OAuth protocol. After we create a reward, we need to create an entry into the event sub system of Twitch, and this is going to be our webhook that Klipshow will receive once a streamer has a viewer that has redeemed this reward in Twitch. So there's a two-step process. We're creating the reward itself. The reason we're doing that is so that we can make sure we have the ID of the reward that is going to be associated to the Klipshow credit and everything, and subsequently pass that into the API request to subscribe to the webhook events for that custom reward. So at that point, we will be set up for a viewer to redeem these channel point rewards on Twitch. Twitch will then send the webhook to our application, and our application will process this in the form of creating a transaction and assigning it to the streamer wallet for this streamer-viewer relationship. One part of this process, actually it does go through it right here, is in the background job, when we are receiving a redemption, we need to make sure that the viewer has a record in Klipshow. So we need to account for the very first time that a viewer redeems a channel point redemption and any subsequent time. So we need to account for that and make sure that we can create the subsequent viewer record for that ID, and that'll associate it to the streamer wallet and make sure that we can process future redemptions as you would expect. So we have to keep that in mind, and we have to do the same thing for the streamer wallet itself. The streamer wallet is going to be unique per each viewer, because the viewer and streamer is what bridges the connection for the Klipshow credits. The credits are not widespread throughout all of Klipshow. They're specific to each streamer. So we have to make sure that that streamer wallet record is created for the very first time that a viewer is redeeming something, and for any subsequent transaction that they may make. And then we're going to leverage the turbo broadcast method in Rails that allows us to activate a turbo stream from anywhere in our application. And we're going to leverage the underlying functionality we have with Anycable that we're using for all of the clip queuing and all of that kind of thing. So we're going to have the status of the channel point redemption listed in real time, and we'll be able to have it reflected when it's pending, when it's active, and if it ever does fail. And we'll make sure that we're capturing those failed states in this asynchronous manner by making sure that in the situation that one of the API calls fails, we're flagging that Twitch channel reward in Klipshow, the record for it we store in Klipshow. We're making sure that we keep that status updated on the record itself, and then in real time, broadcast it with turbo streams, and it will update the UI right away, letting the user know it's either active or something went wrong. Now, since we mentioned that we're going to need to make a few API requests to Twitch, and we might need to make API requests to Twitch in the future, in fact, I'm almost certain of it, it's going to be nice to figure out what we want to use to actually make those requests. My default go-to a lot of the times is to just write the methods myself using the HTTP gem and keep it as light as possible instead of reaching for an off-the-shelf gem that someone may have already created a wrapper for in Ruby for the Twitch API. Now, there is this Ruby Twitch API from a Maurice W, and this very well could work. And the reason I didn't go with it is because I think it's going to add a lot of extra stuff that we're not going to need. It's another dependency. I don't know how well this repository is going to be maintained. The last update that I see right away is from last year. It's hard to say. And so maybe in the future, I'll look to see if there's contributions that we can make to this gem to make it more robust. If that's the case, I don't even know. It may have all of the methods that we need, but what I ended up going, at least in this point in time, is just creating our own service, and it will make the Twitch API calls for us, and we'll limit it to only the ones that will be used. So it'll keep things light, and we'll make sure that everything's tested, and hopefully we'll be able to rely on that for as long as Twitch supports the version of the API that we're using. The pattern that I'm following for this is putting this under lib, and then I'm creating a folder called Twitch, and then I'm creating this base class at the very top here. And what this base class does is it has an initialize method, and it sets up an HTTP client using the HTTP gem that we have installed in our gem file. And it sets up the headers that we're going to need and a instance variable for the base URL. And what this allows us to do are write our classes kind of around the resources themselves and try to reuse functionality like the URL and the client request itself by following this pattern. So for the channel reward itself, to create a actual channel reward, we are having a base class for that under Twitch, channel reward, and then we're following the same convention in the name of our class by using the namespace operator here for Twitch, channel reward, and declaring this as the base class, and then setting this to inherit from our Twitch base class so that we can call the same initialize method from the base class, and then make sure that we're setting our resource to an instance variable for the rest of our class to be able to access. So we're pulling this all out into a class now, and following the same pattern, we're able to add a little bit of custom functionality in the event that the initial creation job for a channel reward failed, and it was created in Twitch's side, but the job didn't complete on our side, and we're missing the ID for it. I have a custom scenario here that will raise our duplicate reward error, which we're just declaring, again, in a very patternistic way, with just declaring it in a descriptive name and then just having it inherit from standard error. And you'll see why in a moment that we're using that pattern, because in the job itself that uses this service, we're actually wrapping the calls to this in a begin rescue block, and we're able to rescue any exceptions that may have been thrown throughout any of the methods that were called in that job. And it ensures that we're able to set the status of that channel reward to failed and then have the UI updated accordingly. So this is the pattern that we're following for being able to make the actual Twitch API requests. And so we have one for the channel reward, and then we also have one for the channel reward event sub. And so this is scoped specifically to the event sub for a channel reward on Twitch. And so it's kind of descriptive as to, we don't have a generic event subclass for all of them. The pattern that we're following here is to have the resource based in the name and have it kind of scoped inherently to what it's used by based on that, right? So we have our channel reward, and then underneath that we have this event subclass. And look, we're inheriting from the previous class so that we can take advantage of that initialize method. And since that parent class inherits from our base class, we're able to use the HTTP client. And I've used this pattern many times, and it seems to work really well for creating just very simple HTTP wrappers that you need to have API access for in Ruby. And now we can test all of these in isolation, and we can add our own custom functionality if we need to here to make it really declarative when it's being used. So in the Twitch channel reward job itself, we're requiring both of those classes, both the reward-based class and the event subclass, because this is where we will actually be calling those instance methods to make the API request to Twitch to have the channel reward created and the event sub request set up so that we can get those webhook events when channel rewards are redeemed from a viewer. I can go over this briefly here. The job is fairly simple. It takes the ID of a Twitch channel reward in our database, and the reason for this is we don't have to worry about serializing the model by passing in the model itself, and it's just an ID that we can look up the actual record for here, and that helps keep everything fresh as well. So every time, if this were to rerun, for example, we would be pulling this fresh from the database instead of potentially keeping a stale record of the serialized version of our model in the database to be rerun by SolidQ. So we're following that pattern here, and right away we're going to set the status of the Twitch channel reward to pending. Regardless of what happens, there's going to be some operations that occur on this model, and we want to reflect that accordingly in the user interface. So we'll set it to pending, and then we're going to call our own broadcast update reward item that we've defined here at the bottom. And this is what actually sets the broadcast call to what ultimately gets digested by Anycable and then broadcasted out to the client. And Turbo uses the default convention for this is the Turbo Streams channel. And then we're able to use those actions built into Turbo for that ultimately will be the Turbo stream that gets rendered and executed on the page to update the UI. So we have two different methods here, as you can see, and what we're doing is we're passing the streamer record in because that's going to be the identifier that it's signed to. And we're doing that so that not anybody can subscribe to these events. This needs to be scoped to this streamer. And you'll see how we authenticate the connections to this now when it comes to the front end of this. So we're making this call, and I'll show that subsequent helper method that we have to call in our view to make it so that this call can be digested. But hopefully you get the idea here. We're going through, and based on whether or not this is a create action, we'll go ahead and try to call the create methods on our new services that we just went over and update the resource accordingly. And at the very bottom here, we rescue out of any exceptions, set the reward to being in a failed state, and then broadcast the new updated version of this reward, which will show that failed status in the UI. So this should be pretty self-explanatory here. We support both creating and updating. The only gotcha that I ran into here was, again, in the event that the first attempt to have a channel reward created on Twitch's side fails and we don't have the ID, we account for that here by saying, okay, although it was the update action, if we don't have a reward ID here, we need to make sure that we're either updating it with the new one or just having it fail by not finding the ID or whatever may happen there. So I think we're handling all of that pretty well, and I think this looks pretty clean here. This allows the decoupling of the services, allow it to be dead simple to test in our specs for all of this, which we've already written. And I don't think I'll need to go into that because it's going to be pretty similar to the previous services and stuff like that we've tested. So for the sake of not having this be boring on our mega episode or whatever we're calling it, we'll just keep it to the meat and potatoes. So that's how the job runs. And then what we've done here in the model for the Twitch channel reward is we're using the after commit callbacks to enqueue our job to either update or create the Twitch reward. And it's nice having it at the database level here because it's very intuitive as to what it is that we're doing. We can come here and see, okay, on update, if any of the Twitch attributes have changed, which is a custom method here, and that just detects that any of the columns that are related to Twitch are changed, we'll actually need to enqueue that job. If not, it's just the Klipshow credit amount, and we can just have that set locally and nothing needs to change. And so these jobs will get enqueued at the database level using these after commit callbacks here. And that allows us to keep the logic for the controller related to just the request. So we're still processing the record in the same way we would anything else. We're using the whitelisted parameters from the front end to actually update the record. And then the actual updating on Twitch's side gets enqueued from these callbacks here. And we're able to reflect those changes in real time to the user using that broadcast mechanism with Turbo that we get. And on the settings page here, in order to make that work, I had to add this here. And so basically, this is the convention for saying, okay, the Twitch channel rewards is the scope of this, and we're passing in the current streamer to be scoped to the resources that will be passed over the wire, right? So this actually just sets up a meta tag that the Hotwire package from NPM, the JavaScript package, will detect and hook up for us. And we're doing that here by importing the Hotwire Turbo Rails. I believe that's doing the setup to be able to listen for the tag that is generated from this Turbo Stream response here. So it uses the Turbo Streams channel by default, and what I came up with to make sure that we can authenticate this with a streamer that has cookies is this right here. So on the subscribed here, we're rejecting unless the current streamer has been found, and the current streamer is going to be found from our base connection class here. So I want to do some more digging in this because I haven't seen a good pattern yet or anything set up with Rails to have privileged channels authenticated differently. It seems to all come in through the base class here, and there's no way to scope it to different resources, at least not that I found yet. So what we're doing in the situation here, this is used for our alert consumer in OBS. It's now used in the public profile for the users to be able to see all of the clips in real time. And it's also used for this privileged channel now. And so regardless of how the end user is connecting, we need to authenticate them and essentially find the streamer to send to the next part of the equation, which will be the actual channel itself that the action cable streams will be coming from. So I have a method here, find streamer by auth token. It just looks up the information in the cookies, which will only get set if the streamer is signed in. So that is our form of authentication there. And then I'm also setting a authorized from auth token instance variable, and we're checking that in the subscribed here. So basically, if we found a streamer from a display name, for example, a display name can be passed in to this request. And in our connection here, if we find a display name and we find a streamer that's associated with it, we'll assume that they're going to connect to the streamer alerts channel, which will give them access to the current clip queue. So the reason that we have to do all this is because if someone were to just pass in a display name into the parameters and we relied on this being our method of authentication, that would be insecure in that anybody could find out the display name of a streamer and reverse engineer how to subscribe to these WebSocket events. So this is what I'm doing so far to get around that. If this flag is not set, if that instance variable is not set, we're going to reject the subscription, and we're going to make sure that that is set only if the viewer or the user, in this case, has a cookie set that we have authenticated and pulled their ID out of using all of our signed keys and that kind of thing. So I'm hoping this will work. If I run into any changes with this, I'll be sure to bring that up. But it was definitely worth calling out that this seems a bit messy. Inherently, there's not really a well-documented way to do this. And so coming up with this on the fly, this is what we have so far. And that is what allows us to go from a background job and call a method that essentially will make its way to the user's interface through Turbo and through Anycable and all of that kind of thing. And at this point, you should kind of see that although it's a little tricky with some of this stuff, the inner workings are already laid out for us, and we're already able to reuse a lot of functionality and infrastructure because we have this Anycable stuff set up, and it works well with ActionCable, and so anything that uses ActionCable should just work, and this is a great example of that. So if we test this out here, you can tell I've been kind of messing around with this. We currently have a situation where our reward is set up. It's showing as active. We have it assigned to 100 channel points with Twitch. It redeems 10 Klipshow credits, and I can confirm that this works here. And I'll give you a little preview into Klipshow or into OBS here and what I see. This is the corresponding reward that is associated to this in Klipshow. And if we make a change here, if we increase this to 1,000, we'll see that will go to pending. It'll move back to active almost instantaneously. There's a small delay. And what's happening is that background job is running. It's making that update call to Twitch. And if we look here, that change is reflected. I didn't have to do that. And so that immediately confirms that this kind of relationship is working. And although it seems complex, and it relatively is, it is all working together with turbo frames, and we're wiring the entire experience together, including the forms and editing it all with just turbo requests. So turbo frames for this, and then turbo streams to update everything. And then to actually test when we go to redeem this, I'll go ahead and redeem it. And you can see here, it shows that it got redeemed. And I have this set up with ngrok. And the reason that we have ngrok set up, ngrok is a service that tunnels the outside internet to our local developer environment. And the reason we need that is Twitch needs to send us a webhook challenge to verify that it is Klipshow that is requesting to sign up for these webhook events, and there is some authentication that we have to do there. There's a signature that Twitch will include in every webhook HTTP request, and that's to verify that the webhook can be trusted from Twitch, and we can process it, and it's a security mechanism to prevent anybody from exploiting the webhook channel and sending in a web request and having credits created or something unanticipated. So we can see earlier when I was still getting this working, we were having some issues, but we can see this is a request that just happened, and I already have a console set up here. The previous amount of credits that I had on this streamer wallet, there's only one streamer wallet in the database, so that's how we can check that. The previous balance was 11, now it's 21, which is corresponding to our credit here. So that really gets us in a fantastic place to set up the ability for users to sign in from our public profile here. And we have this hard-coded still because we're going to need to have a viewer record that we can use on the incoming request for this profile so that we know what streamer wallet to load and subsequently what balance to have reflected here. And we'll also use that for adding the credits if we're going to do that with Stripe Connect, or it'll essentially be the same mechanism that will happen with Twitch Bits as well. So this is all working in development. So in summation, we have our new settings area set up. We have the functionality needed for the streamer to create a Twitch channel reward, and we have the functionality set up to enqueue that in a background job. We can also monitor all of our jobs here using mission control. We've gotten this set up. You can see now the finished jobs are showing. We're able to have the entire payload that was enqueued with these jobs stored, and we can look at anything that was failed. This was a great thing for me to look at in the development process, getting the kinks worked out. We've gotten that set up, and the next step is going to be getting this deployed in staging and making sure that we are able to actually have this work with our viewers in the staging environment. So that is the next thing that we'll work on, but we are making tremendous progress with all of this, and it is coming together quite nicely. So I will get on the next part, which is making sure that this can get deployed. We have a little bit of infrastructure changes with the new database for SolidQ, and I'm hoping that we'll be able to get that worked out, hosted, and then we can start advertising this for test purposes and start to get the feedback of potentially some streamers that we can have use this outside of just ourselves. Okay, so I'm happy to report that we have all of our changes on our staging environment. We got it working with Kamal with pretty minimal hassle. The biggest thing that I'd say I ran into is I did have to upgrade the droplet size in DigitalOcean to have twice the memory because we were running out of memory, and it was just making our deployment processes like freeze. So that took a little bit to figure out. And we also had to install the DigitalOcean droplet like metrics tool on our instance in order to get access to the memory heuristics. So you can see here, like even just now, we're at like 48% of 2 gigs. So it makes sense that that's the case. And part of the reason for that is we're now having Puma run our SolidQ runner and like the schedule and all that kind of thing. And in order to do that, it comes by default with Puma like ready to go, it looks like, at least with the newer versions. And all it is to make the SolidQ run in the Puma like worker process, you just have to set the environment variable SolidQ in Puma. This line was already here in puma.rb, so I didn't need to do that. So we have a lot running on this box now. We have the Anycable instance for the connections, we have Postgres, we have the Rails app, and now we have another forked process of Puma that's running our SolidQ. So everything seems to be working well, but we're going to need to start reevaluating this to be able to scale a little bit easier, because right now, having everything on one machine and not having a load balancer in front of our application logic stuff is going to be problematic for needing to upgrade. So it's great for now because we're just trying to get it tested and working out the bugs and that kind of thing. But I bring it up because it's something that we're going to have to start thinking about. So we are confirmed working. I have these channel points set up now, and this is in it's staging, but it's our only production environment that we have right now. And I've confirmed that by updating the channel points or the description or the title, it does change to pending, like I can show you here. So it'll go pending and then active. And we mentioned how that's happening just in the previous, not episode in this episode, but in the previous like clip of me recording, I went over that and how that's all happening behind the scenes with our new Twitch channel reward job. And what we're doing behind the scenes now is setting up all of the webhook stuff, and we've already gone over that. And so the way that we designed it, in order for this to just work in a different host than our ngrok host, we just set the host name environment variable differently in our deploy file. So that was all that we needed to do for that. And then everything else seems to be working. So that's fantastic. And then if we go here to the profile, you can see that this is what loads. I already have this loading. You'll see that this is no longer a placeholder just showing a static number. This is actually updating now live when we redeem channel points. That's the only way to create a transaction for adding credits to your streamer wallet here. And we have this hooked up with Turbo so that when we enqueue this here, it will, in the back end, check to make sure that the current viewer is signed in. We do that here at the top, so I'll go ahead and redo that. It redirects you to the dashboard page there after sign out. So if we go sign in, I'm already signed into Twitch, so it's just going to redirect right away. And now I can see my credits, and if you look before, we saw a little preview showing that we're not signed in, and we need to do that in order to see our credits. So it should be pretty self-explanatory there. And we can go ahead and make this work. And I'm streaming in OBS right now. We're streaming live, and I have this all hooked up, so you'll see it come over the screen right away.
Hey, Putin, I got 5 words for you, sweetie. Never made it as a wise man. Come on.
Great clip. So that's working. The enqueues is working. And then if you also notice, as soon as we clicked the add to queue, our credits decreased. So if we do another one here, it's like a short one.
Sticks and stones, love.
We had deducted 1 credit there, another 1 credit there. And I think I'm going to have this, we might change this to stay sticky so that you can see your credits as that's going on. But this will illustrate everything. The first things that are jumping out at me that we need to start tackling next is actually hooking up the views for all of this. So when a viewer adds a clip to the queue and redeems credits for it, we're going to deem that as a view that's kind of like restricted to only spends, right? I don't want the views of just me triggering them to be recorded because that's not going to be as meaningful. And then also update the view on the parent clip as well, so that as an aggregate, we can see how many views these are getting, and that should come in handy later for advertising these like clips to be able to add to the libraries of other streamers and that kind of thing. So that'll be exciting. And so, yeah, we have all that working. Some other stuff.
Oh, God! Don't just stand there! Throw me a spear!
Nice. Okay, the skip works. So really the only things of note that I ran into with writing out some of the integration tests specifically is now that we're using that Twitch reward job in some of this logic for our settings area, for the integration test, it brought to my attention that we needed to specify the correct queue adapter. And by setting this to test, whenever your test suite encounters code that calls one of the active job perform methods, like perform later, is what we're using now, it won't actually perform that job right away. It'll enqueue it, and then you can make assertions around the jobs that are enqueued. And in situations where you're testing the job itself, you can have the job actually enqueue, or actually perform rather, and write assertions around that as well. So that was really the only bugaboo that I found there. Other than that, there was just a lot of moving parts to get this working with the turbo streams and everything else. Since we are now using a viewer record for the first time, it's worth going over our approach with all of that. So I'll go over how this kind of sign-in procedure works here. So by default, when a user goes to this page, even if they're signed in on their streamer dashboard, it'll still show that they have to sign in because this is treated as a viewer record, and in the dashboard it's treated as a streamer record. We're starting to get into some of that logic that we need to have differentiated, even though they're both underlying user records in the database. So what this does is I have a controller set up now to kind of act as a proxy between the front end here and the OAuth request that will be sent to Twitch, the same OAuth request that is sent when a streamer signs into their streamer dashboard. The only difference here is we're adding another parameter to that query in the request that goes to Twitch, and it's called the state parameter. And in OAuth, it's a convention used to be able to track stuff like what we're doing here, with namely being able to automatically redirect back to this profile that we're on here after we click on this. And this prevents us from having to use any kind of React component and having to spawn another window or anything like that. So although it may be a little not ideal in the sense that when you click sign in, it reloads the page, but it's a very simple implementation of how this works, and I think it's a totally fair trade-off for that. So when we click sign in, I'll go over the new setup that we have for that. Yo, Kodiaks, what up, baby? As I can see, the loadings of the images are kind of slow. Isn't the database matter? Are you just at the real beginning? Sorry for this kind of dumb question. I'm new here and just checking out what you did. At first looked very nice, a nice idea. Something went wrong. JSON parse expected line. Okay. Kodiaks, yes. So basically, it's a great point. We ran into a situation here. If you can see this, it says access denied. These are actually TikTok iframe previews. So the reason that it's slow is each one of these clips is actually loading its own iframe. And that's just, I mean, as we're seeing now, it's just not going to work. I think TikTok is detecting this as like bot activity. And so we're going to have to implement the ability to have like a preview image stored for a screenshot for like the preview of these clips, because we don't really need to have the iframe of the clip itself loaded in each one of these. I was doing that as kind of a cheap way to just have like that functionality, but we're definitely going to have the this fixed with being able to show our own preview that isn't dependent on TikTok so that this doesn't happen. So yeah, this has nothing to do with Klipshow. This is just an iframe for TikTok, and the reason it takes so long to load is because of TikTok stuff. Okay, we had a slight issue there with testing this. I didn't have the logic worked out correctly to have the right streamer wallet found upon a user signing in. And the reason that that slipped through the cracks, totally being honest and transparent here, as I have not written the integration tests for the profile yet. I'm very excited to get episode 7 done. I've been working tirelessly on this. So cut me a little bit of slack there, but we found it thankfully to one of our devout streamers, or one of our devout viewers, and he saw that and we got it fixed. So basically, the next thing that is worth going over here is going to be our OAuth sign-in like process for the viewer flow. Let's start at the routes file. So in the routes file here, I'm trying to be a little bit better with the namespace from the beginning, because I mean, this definitely makes sense in this space here. So I have a namespace for viewers, and then we have a nested namespace for Twitch, and then we have two different ones here. So sign in and log out, and those will go to an OAuth controller that it's not the same OAuth controller as this one here, because it's nested in this namespace. So it's actually going to be under viewers, Twitch, and then OAuth controller. So in our viewers, Twitch, OAuth controller here, we declare it this way, and this matches the nested directory structure. Can be a little easier to see it in the tree here. So we have viewers, Twitch, OAuth controller, and then we name it that way accordingly. And this is that like proxied request essentially. And the reason that we're having this proxied request is we're adding this signed state parameter to the OAuth request that gets sent to Twitch. And Twitch is following the OAuth protocol correctly and having any state parameter that is passed in to the request to gain an access token to be passed back for this very purpose. What we're doing here is being able to store the profile that the user's on and have that persist through the connection to Twitch from the user side back to Klipshow and confirm that in between those requests it hasn't been tampered with at all. That's mainly the reason here. Once we have the signed payload in the browser, they'll still be able to see it, but it'll be encoded with our secure verification here, which is a built-in Rails secure message authentication like verifier, I guess you could say. I used a bunch of dumb words there, but hopefully you get the idea of what we're trying to do. Basically, it'll take in this case, a hash. And another notice here, we're not using this nonce in any other way other than just trying to add entropy to the end string that will get output as the signed state. So it's an encoded string that can only be decoded with our application secret key. And that's the secure mechanism that we're using to being able to send this out to Twitch, which hopefully it goes to Twitch, but it could go anywhere and then come back, and we can verify that it is a legitimate request having this parameter included by verifying it in this way. So hopefully that makes sense. And then for logout, we're just doing the sign out method, which we've added into our authentication or authenticatable concern here, and we can go into that. So just like we have for the streamer, we have kind of the equivalent for viewer in a lot of the ways here. So in the OAuth controller, let me back up a little bit. In our proxied request, we're redirecting them to the Twitch OAuth signup. So this is the same URL that we have the streamers currently going to just in the browser. The reason we're adding this step here is to securely add the state to the parameters. And then what will end up happening is the request, it'll go to the same OAuth controller that the streamer sign-in request goes through as well. And since we're using this state param that we can rely on because we can verify that it came from us originally, even though it's being received from the outside internet, which is very scary, we can confirm that, okay, in this state here, if a streamer signs in, we're going to set the necessary cookie for a streamer to be able to access the privileged areas of the application. If there's a state and we are, the only reason that we're using state right now is for a viewer, we can have the flow here set the necessary cookie for the viewer. And you can see that here. So down here, we have kind of abstracted what was the streamer before, and we're just calling it resource. And we're basing this off of if there is this state param passed in. If this state param is passed in, that means that it's a viewer signing in, and we can set the resource accordingly. So the resource here is just an abstraction of either a viewer or a streamer, and that way we can reuse this same exact code for both the streamers and the viewers. And basically, we add a few other conditions here. So we're setting two different cookies, one for the viewer, one for the streamer. And a streamer can be signed in as both. And that's completely fine because we need that relationship between a viewer, even if it's the same underlying user record, and a streamer. So we differentiate the two by storing them in different labeled keys in our signed cookies here. So if it's a streamer resource that we're dealing with, the key that we're going to store, what comes back from the token service generator, goes in the streamer auth token. Otherwise, it'll go in the viewer auth token key. So it allows us to reuse most of the code here. And then the only other thing is down here, if we've set this redirect streamer or streamer to redirect to, which is pulled from our state when we go and verify that information, which I can find here. So if state is present, we will go ahead and extract the payload from it. If the payload fails, indicating that it's been tampered with, this exception will get raised here. We'll set this alert, and we'll stop this from happening. We won't set any cookies because that's an illegitimate request. So that's our protection there. And we're also just at the bottom differentiating where to redirect to. So if we have state, we know that there should be logic in place to redirect to a streamer's profile. And if it's a streamer, we know that goes to the dashboard path. So we're just doing that here. And yeah, I think that works really well. We're able to leverage that same flow, the same function, and modify it slightly to work with both viewers and streamers, leveraging that underlying Twitch OAuth kind of authorization. What we need to do here in the actual actions component. And what I mean by actions component is this at the very bottom here is its own component. And we swap these out based on where the clip card is being shown. There's a few different places in the application that we're leveraging this, and this is functionality that just swaps out based on that prop flag there. So in the add to queue component here, we take into account that there's a new parameter being passed in from viewer. If the queue is coming from the viewer, we need to use a different endpoint because we are actually tying this to a transaction instead of directly creating a streamer clip queue. And we're just basically building the request ever so slightly differently based on the fact that we have a viewer here and the endpoint is different. So in this viewer's transactions controller, we are doing this in the same namespace as viewers, just underneath the Twitch, and we are using resources. That's where this is coming from. So far, we just need a create action, and this is where the viewer is able to create a streamer clip queue if they have the balance in their streamer wallet for it, and this takes care of all of setting that up. We leverage that streamer wallet transaction service that we created earlier on, and that will make sure that this only will succeed if the balance will not be negative. We do not support a negative balance. So regardless of what this amount is going to be, it won't persist unless that is the case. We're leveraging that same concern here for the streamer clip queuable. That's the same thing that we're using on the profile controller, if I'm not mistaken. And the reason that we're doing that is to have the actual streamer clip queue created. And in that concern, we have the response triggering that toast message. We can take a look at that now as a refresher. So we are basically using this method here for anywhere streamer clip queue is created, whether it be in the dashboard or in the streamer's profile view. So in order to have this work, we just needed to abstract the triggered by here. Before, we had this hard-coded to the current streamer. Now this can be called by either the current streamer or the viewer here. So following the pattern of these concerns, we're able to see that by having our endpoint be hit here, we can set that instance variable and then call that method, saving us from having to write all of that logic over again. And this also takes care of that JSON response that our KS fetch function can digest and display those toast messages with. The last piece of the puzzle here, really, other than just setting up some boilerplate with getting the streamer from the request that's coming in order to get the streamer, we're just passing in the display name and validating that it is tied to an actual streamer and then rejecting the request if it's not. The last piece of the transaction side of things is our broadcast update 2 that we're using. And we're doing a very simple update here. You can have the HTML updated without passing in a partial or anything like that, because all we're doing is updating the new balance that is reflected after this transaction took place. And that's nice to be able to give that feedback directly to the user. And we're just putting that in its own method and calling it in the same convention that we were in the Twitch channel reward job. It's really nice to be able to do this. So, you know, in situations where the functionality doesn't need to be super dynamic inherently, being able to rely on this is actually really nice because it prevents us from having to add more JavaScript, and we are able to kind of keep things wired together, even though there's different contexts that this is all operating in within our application. So very exciting stuff when patterns come together and all that. It just kind of feels right, you know, and we're able to focus more on the intangible stuff, which is what do we need to focus on to make this a viable product, right? So that's my TED Talk for the episode. I don't think there's anything else that we need to go over for this. I think that this is in a very good place. We are able to, we've confirmed the functionality here. We've actually confirmed through a viewer, our viewer that is always in here usually for the development of this stuff, was able to christen Klipshow by being the first viewer to have this display and found the issue with the wallet there, which was fantastic. And this puts us in a really good place to build out the Twitch extension and wire that up to have bits involved. Another thing that I mentioned earlier is we're going to have to wire this up to actually record the views. That's something that is going to need to be on the immediate agenda. And a few other things that I have cooking, but I think for the most part, this puts us in a really good place to start, you know, having it used not only from the streamer side, which we've had for a few episodes now, but from the viewer side, which is arguably much more important. So we are going to go ahead and call this episode here. That is going to be the end of it. We went over a great deal, and we'll go ahead and wrap up now. If you didn't come to this conclusion already yourself, we did cross a major milestone by getting all of this work done. We now have an application that works not only for a logged-in streamer and for streamer-exclusive access, but now a viewer without any intervention from the streamer can go onto a public profile hosted by Klipshow, redeem credits, and have these clips actually display on stream. That is like 90% of what the MVP is for Klipshow, and a lot of applications never make it to this point. I can tell you from experience, a lot of applications that I've worked on before have fizzled out, and it never saw the light of day. So regardless of if Klipshow is ever anything more than just this build series and the experience that our stream can have, I am totally happy with that, because this is we're making history, even though it doesn't seem like a big deal. It really is. The technical complexity that we tackled here is no joke. We got solid queue up and running, and I was a little worried about that because it's the very first time that I've actually used solid queue, and I'm starting to feel better about that decision because it seems to be working really well. And once we have this battle tested and in production a little bit longer, we'll have confidence that we made the right decision by not having another service like Redis that Sidekick would rely on that I normally use. So I'm very excited to see how that performs under load and how it scales, and I'll be sure to share all of that. But just getting it working at first is a huge accomplishment, and we were also making sure that all of our Kamal deployments, while making these changes, worked, which they currently do. We have some workflow that is failing in GitHub right now, and it's our test suite isn't passing in GitHub Actions, but it is testing locally. So that's going to be a fun issue to debug, but we'll get that taken care of. And other than that, the functionality as it exists exist right now is still working, even though we still have some kinks to work out. In the next episode, the very first thing that we're going to tackle is getting away from using the TikTok iframe for every single load whenever we load those clips up. What we're running into already are myself and other users getting banned temporarily from TikTok for what I'm guessing is what they're considering bot activity. And we can get away from having the TikTok serve as the actual iframe by using the TikTok API, I'm hoping, to provide us with a screenshot URL that we can store on the clip record and then load that preview instead of having the TikTok iframe serve as our preview for us. It'll be a win for not having to hammer TikTok with as many requests, and it'll be a big win for Klipshow users because the performance will be improved substantially, as we'll just need to load a simple image instead of an entire iframe before we see what those clips represent. I don't want to settle for the functionality we have right now with our users just being able to redeem Klipshow credits with channel points. I want to expand on that. So the next thing that we'll probably work on might be Stripe Connect, to be able to use a credit card to purchase Klipshow credits, and then that'll segue nicely into our Twitch extension, which will actually be kind of a single page application all on its own, and you'll see that process. I've been through it once, and it can be a little tricky, so that'll be fun to go over, and I think we'll cover that in the next episode as well. But if anything, we should start getting excited that other streamers should start being able to use this, and we'll have an idea of if this will have viability in the marketplace. Something I'm very excited about because it's a dream of mine to make something like Klipshow or another one of my projects sustain my full-time living so that I can do this instead of having to work a 9 to 5. If you're enjoying this build series, please hit that subscribe button and turn on that bell notification so that you catch the very next episode that comes out. We're building something very special here, and you're not going to want to miss what happens next. Jump into our Discord community. Again, the link for that is in the description. And go follow, if you haven't already, my live stream at twitch.tv/oddjob, where we do hardcore coding sessions peppered in with a little bit of gaming when we need to decompress. Thank you for watching. I've been Johnny. You've been fantastic, and I'll see you in the next episode.